Hello learners, welcome back to Vizartus. Today we're going to be studying Class 8 Physics, Chemical Effect of Electrical Current. When electricity passes through any conductor, different effects are observed. These are called effects of electricity. We have already studied these effects in our earlier classes, so let's do a quick revision. The first one is heating effect. When a metal coil is attached to a battery, it gets heated after a while. This exactly is the heating effect of electricity, where heat is generated whenever electricity passes through a conductor. The next effect is magnetic effect. Let us take a battery connected to a screw with a wire. This wire is wound around or wrapped around the screw, as you can notice over here. Now, according to the magnetic effect, a magnetic field is generated around this screw. Now let's take an object made of material that is attracted by magnets. Such a material is called a magnetic material. Placing this object near the screw, we can observe that it gets attracted towards the screw. Thus, we can say that the screw has become a temporary magnet that shows magnetic properties as long as electricity flows through it. If we were to stop this flow of electricity, the screw would not remain a magnet and thus would not attract the magnetic object. Another observation of magnetic effect is that of deflection of a compass needle. We know that the compass needle, that is over here, is made of a magnet. So whenever we wind electricity carrying wires around a compass, the magnetic field thus generated causes deflection. That means it moves to and fro, or it has a small movement. It may be possible that the wire near the north pole of the needle, so let's assume this to be here, the wire near this north pole exhibits north pole properties, so both of these are north, and thus repels the needle, causing a short movement, or vice versa. That is, we know that north repel each other, so do south and south. So when this happens, this needle would want to move away from the wire, and thus it would show a small movement towards this direction. This exactly is the deflection that we observe. Now let's understand electricity conductivity. Electricity conductivity is the property of a material to allow electricity to pass through it. And how much? Based on these property, materials are divided into two types, conductors and insulators. Conductors are the materials which allow electricity to pass through them efficiently. Insulators are the materials which do not allow electricity to pass through them. Now let's conduct a conductor test which will help us identify the materials that are conductors versus insulators. Let us connect a simple circuit wherein the positive terminal of the cell is connected to the positive terminal of the bulb. The negative terminal of the cell is wrapped around the plastic part of a screwdriver. Then the negative terminal of the bulb again is connected to the plastic part of the screwdriver, as you can see over here in the diagram. A few terminologies that one must know. The positive terminal is called an anode, and negative terminal is called a cathode. After a while, we can notice that the bulb does not light up. This means that the plastic does not allow electricity to pass through it, and therefore the circuit remains open. When the circuit is open, there is no complete flow of electricity. So electricity should flow like this in a loop, right? In a continuous loop. But this does not happen. Instead, electricity stops over here. It does not move ahead of the plastic part of the screwdriver. Hence, we can say that this plastic is an insulator. That is, it does not allow electricity to pass through it. Now let's try connecting the circuit through the metal parts of the screwdriver. After completing this connection, we can notice that the bulb lights up. Hence, we can say that the metal part of the screwdriver, which is made of steel or any metal, is a good conductor. That means it allows electricity to pass through it, thereby closing the circuit, allowing the complete flow of electricity, and thus lighting up the bulb. It's not necessary that only solids are conductors. Liquids can also allow electricity to pass through them. Let us do a liquid conductor test to see which liquids are conductors and which are not. Let's create a setup like this diagram, where the wires connecting the negative terminal or cathodes of the bulb and the battery or cell are kept loose, like you can see over here. These loose wires are then dipped into any liquid solution. Here we've taken this liquid as lemon juice. We can observe that after a while the bulb lights up, but very faintly. This means that even though lemon juice allows electricity to pass, only a little amount of electricity is passing and reaching the bulb. The bulb requires more electrical energy to light up to its full potential or full brightness. Therefore, for liquids which do not allow a lot of electricity to pass or with high resistance, this is not a suitable test. Instead, we replace the bulb with a compass. Here again, I have kept the liquid solution as lemon juice and we have replaced the bulb with the compass. According to the magnetic effect, if electricity passes through the wire wrapping the compass, we can observe that the compass needle displaces, which is exactly what happens here. And therefore, lemon juice is a conductor of electricity. Replacing lemon juice with tap water, we can observe similar effects. This means that tap water as well is a conductor of electricity. But if we take distilled water in its place, the compass needle does not deflect. Hence, we can say that distilled water is not a conductor of electricity. Here is a table listing different liquids. Let us check whether they are conductors or not. So, when we dip the loose wires in vinegar, we can see that the compass needle deflects. Therefore, it is a good conductor. Tap water also causes deflection of the compass needle. So again, it is a good conductor. Vegetable oil does not show deflection. That means it is a poor conductor or an insulator. Milk also shows deflection, so it is a good conductor. Honey does not show deflection, thus it is a poor conductor or an insulator. From this, we can conclude most liquids that conduct electricity are solutions of acid, bases, and salts. Now you must be wondering, how do these liquids conduct electricity? Why do some conduct electricity and why do others don't? Let us take this liquid for example, with the loosened ends of the wire dipped in it. If this liquid has some salts in it, then the ions or charged particles get dissociated whenever electricity passes through them. So suppose electricity is passing through these wires like this, then the ions which are present in the liquid will get disassociated, which means that they will get excited and start moving to and fro, like back, back, front, like that. A few terminologies to know. Positive ions are called cations. Negative ions are anions. The positive charge is called a proton. So the red charges you see over here are called protons. Negative charge is called an electron. The green ones over here you can observe are negative and therefore electrons. Coming back to the explanation, when these ions get dissociated, they get charged. They will start moving. And because they start moving, they allow a flow of electricity. In liquids that do not have salt, for example, distilled water, there are no such ions. And if there are no ions, none of the movement of ions takes place, thus electricity does not flow through it either. So this is the reason why electricity flows through tap water and not distilled water. Tap water has different minerals and salts, which give it ions, but distilled water does not have any. We have already studied two different effects of electricity. Now let us study a third one, that is, chemical effect of electricity. The first chemical effect of electricity is formation of bubbles. When you create a circuit like the one shown here with electrodes, that is, carbon rods dipped in a container of water connected with a circuit, you can observe that eventually bubbles start coming out near the electrodes. This is a chemical effect. Another chemical effect is change in color. This change in color means that when you connect a circuit with a potato, that is a circuit that passes through a potato and is connected with wires to the potato, like here, these wires over here are connected to a potato. Eventually, the side connected to the positive terminal, that is the anode, starts turning greenish blue. Therefore, if we connect a circuit like this, a greenish blue spot is noticed or observed in the area of the connection at the anode. Now, if you're wondering why we've kept a compass, it is to check whether electricity is flowing effectively or not. Suppose we connected the circuit without the compass, then there is no means that we will know whether electricity is flowing or not. There could be a chance that electricity is not even flowing, and therefore you will not get the desired observations. So, this compass helps us ensure that electricity is flowing. Now, coming back to this effect, the chemical effect of observing a greenish blue spot at the anode helps us identify the positive terminal. Another example or application of chemical effects is electroplating. Let us take a container of copper sulfate solution. This solution is blue in color, as you can observe here. Now let's put a few drops of dilute sulfuric acid in the copper sulfate solution. We also need two copper plates. Ensure to rub them with a sandpaper so that there is no rust. We don't want rust or any unwanted impurities on them, which can disturb the experiment. Now let's connect a circuit with the copper plates with the loose ends of a wire connected to these plates. Dip these copper plates in a copper sulfate solution. After a while, you can notice that the copper plate at the anode starts thinning. That is here. And the copper plate at the cathode starts becoming thick, as you can see here, because of apparent copper deposits on top of it. So you can notice that there is certain extra copper on top of the original copper plate. That is, some copper deposits are observed. Let us understand at a microscopic level, why does this happen? The solution of copper sulfate is connected with two wires, a positive and a negative. Now, the copper sulfate molecule has two ions, copper, a positive ion, and a sulfate that is SO4 negative ion. We know for a fact that positive ions get attracted towards negative and negative charges get attracted towards positive. Similar thing happens here. The copper ions, which are positive, get attracted towards the cathode. Connecting this understanding with our experiment, there is a bunch of positive copper ions in the solution. And when electricity passes through the circuit, these positive ions move towards the cathode copper plates, and therefore copper deposits are observed. Now, there is a deficit or deficiency of copper in the copper sulfate solution. To make up for this deficiency, the copper ions in the copper plate connected to the anode start dissociating and go into the COSO4 solution, that is, copper sulfate solution, to fill in for the lack of copper ions, which went on to become the deposits. Because of this loss of copper ions from the connected anode copper plate, it starts becoming thin. This is exactly how this process works. Therefore, we can say that electroplating is the process of depositing a layer of any desired metal on another metal by the means of electricity. The layer of metal deposited has some desired properties which the metal of which the object is made of lacks. Now, this desired property is mostly of an expensive metal, and it is not economical to make the entire object out of the expensive metal. So the entire object is made of some cheap metal, and then the expensive metal with desired properties is electroplated on top of it. This way, the object is cheap while pertaining the useful qualities of expensive metal. Electroplating is used in different industries. Let's have a look at a few uses of electroplating. First is chromium coating. Chromium has many desired properties like it is shiny, it does not corrode, that means it does not rust, it does not get scratched easily, that is, it is scratch resistance, but again, it is expensive. So we use electroplating to electroplate chromium on top of an object made of some cheap metal, and therefore the price of that object decreases, but it also has the good properties of chromium. Cheap jewelry is also made by electroplating gold or silver on less expensive metal. These ornaments have the shiny and rich looking appearance of silver or gold, but are much less expensive. Tin cans used for storing foods are made by electroplating tin onto iron. This way, they have the strength of iron, but as iron is more reactive, the reactivity of iron is suppressed by tin that is electroplated on its outer covering. And therefore, the can is sustainable, that is, it lasts longer because of iron, as well as it does not react with the stored food because it has a tin coating. Galvanization is a method to reduce rusting. Iron is a strong metal and is used in different constructions, but it has one disadvantage, and that is it rusts easily. To prevent this rusting, it is electroplated with zinc, so the inner part is iron to get the strength, and on top of it, there is a coating of zinc which protects it from corrosion and rusting. Here is practice homework for you all from NCERT. Fill in the blanks. Most liquids that conduct electricity are solutions of dash, dash, and dash. The passage of an electric current through a solution causes dash effect. If you pass current through copper sulfate solution, copper gets deposited on the plate connected to the dash terminal of the battery. The process of depositing a layer of any desired metal on another material by means of electricity is called dash. We have already studied all of these concepts, so these questions must be really easy for you. It is very important to practice NCERT questions, so do solve all of them for better understanding and better scoring in your examinations. Thank you so much for watching this video. I hope it was of great help and use to you. If it was, don't forget to like, share, and subscribe. Bye bye.